GeopByte.
Welcome to GeopByte. Hi students. In the previous video, we have completed chapter number 1. In this video, let us start chapter number 2, Polynomials. In that, let us cover Introduction to Polynomials, Polynomials in one variable, Example problem 1 and Types of Polynomials. Now, let us see Introduction to Polynomials. Right? In our previous classes, we have seen algebraic expressions, their addition, subtraction, multiplication and division. And we have also seen factorization of algebraic expressions. Right? Some of the algebraic identities are x plus y whole square is equal to x square plus y square plus 2xy. Right? It is in the form of a plus b whole square, a square plus b square plus 2ab. Right? This is one identity. And one more, x minus y whole square is equal to x square plus y square minus 2xy. And also x square minus y square is equal to x plus y into x minus y. So these are some of the identities which we have seen in algebraic expressions. Right? Now in this chapter we are dealing with the study of type of algebraic expressions called polynomials and its terminology. Now, let us see polynomials in one variable, right? It means a polynomial having only one variable, right? See, let us consider a square A, B, C, D. This is my square A, B, C, D. Now, each side has x unit length. Right? Each side is having x unit length. Now what is the area of the square? Area of the square. Side into side. Right? Area of square is nothing but side into side. Here we have 4 sides. Means we need to multiply side into side. That is x into x. Now x into x is nothing but x square, right? This is a polynomial having only one variable, right? Now let us see some algebraic expressions. X cube minus x square minus x plus 2. This is a polynomial having only one variable. That variable is nothing but x, right? Here we have only one variable as x. Other than x, we have constants. But variables we have only x in this algebraic expression. And let me take 3y square minus 2y. Right. See, this is a polynomial having only one variable. What is that? It is nothing but y. So here I have only one variable which is y. And I have also constants, but in variables I have only y. And let me take another polynomial, t square minus 4. And here I have only t as a variable. This is also a polynomial having only t as a variable. So, these are some of the polynomials having only one variable. Now, let us see the concept of coefficient. Right? In a polynomial, each term has a coefficient. Now, if you see, let us take a polynomial minus x cube plus 5x square plus 3x minus 4. Now this is my polynomial. Here for each term I have a coefficient. That is for minus x cube. For minus x cube I have coefficient as -1. And for x square I have coefficient 5. Right? These are coefficients. Here nothing is there. It means it is 1. Right? Here we have 5 and for x we have a coefficient of 3. And see, for 4 we will be having x power 0. Right? X power 0 is nothing but 1. So, 4 x power 0. It can be written like this. Now, for x power 0 it is nothing but 4. Now you see, for minus x cube, -1. For x square we have 5. And for x we have 3. And 4 can also be written as 4 into x power 0. Not only 4. Any constant can be written as the constant into x power 0. Because x power 0 is equal to 1. So, now x power 0 is written and the coefficient of x power 0 is 4. I have written 4. So, these are the coefficients of polynomial expression. Now, see, if a variable in a polynomial is x. If a variable in a polynomial is x. So, the polynomial can be written as, see, now let us take a polynomial of x. So, x cube plus x square plus x plus 1. Now, this is my polynomial. It can be denoted with p of x. See, polynomial of the variable x. Here I have variable with x. So, I have taken p of x. Now, see, we can also denote with, let me take a polynomial, x square plus x plus 2. Right? Now, this is also a polynomial with the variable x. So, I can take it as q of x. Now, let me take a polynomial with variable y. 4y square plus 3y plus 6. Now, see, this can be denoted as r of y. Right? So, my polynomial of variable y. See, here the variable is y. So, we will denote it like this. Now, let me take some u. U as my variable. 2u square minus 4u plus 2. Now, this polynomial has the variable u. I can write it as some s of u. Like this. So, we can write the polynomials with variables like this. That is, we can denote with p of x or q of x or r of y or s of u. It's our wish to take the alphabets, but the variables should be what are they here. Now, let us see what is a binomial. Binomial means nothing but a polynomial having only two terms. For example, let me take x plus 1 and x square minus x or some y power 6 plus 1 like that. So, the polynomials which are in this form, that is the polynomials having only two terms in it, are called binomials. Now, let us see degree of the polynomial. Degree of the polynomial. First, let us take a polynomial x cube plus x square plus x plus 1. I am considering a polynomial of x cube plus x square plus x plus 1. Right? Now, in this polynomial, degree of the polynomial means the variable which is having the highest degree, right? See, our variable in this is x. Now, what is the highest degree here? For this x, we will be having 1. X power 1 is nothing but x square, x cube. So, here my degree of the polynomial will be 3. Right? We need to find out the highest degree of the polynomial. It is nothing but finding highest degree of the polynomial. Right? So let me take another example. Y power 6 minus 2 y power 5 plus 3 y power 4 minus 6y cube plus 2y square minus y plus 8. Now this is my such a big polynomial. Now here you see what will be the degree of the polynomial. As I said, the highest degree. Here which one is the highest? See, for y we have 1 and 2, 3, 4, 5, 6. Right? Here we have 6 as the highest degree. So, the degree of this polynomial will be 6. So, we need to check the highest degree. Now, let us see example number 1. Find the degree of the polynomials given below. Right? Below we are given with 3 questions. We need to find the degree of the polynomial in each question. The first one is x power 5 minus x power 4 plus 3. Right? As we all know, degree of the polynomial means finding out the highest degree of the variable in the polynomial. Here our variable is nothing but x. For x, we have powers 4 and 5. Among these two, 5 is highest power. So, the degree for this polynomial will be 5. Right? The degree of this polynomial will be 5. Now, let us see second polynomial. Here we have 2 minus y square minus y cube plus 2 into y power 8. Here we have variable as y. For y, we are having powers 2, 3, 8. Right? We have 3 powers 2, 3 and 8. Among these 3 digits, which one is bigger one? 8. So, 8 is the degree of the polynomial. Right? For this polynomial, the highest degree, that is the degree of the polynomial will be 8. Now let us see third one. If you see here, we have only 2. Right? See, 2 is a constant. Now 2 can also be written as 2 into x power 0. Right? 2 into x power 0. As I said, x power 0 is nothing but 1. Remember this, x power 0 is nothing but 1. So, 2 into 1 will be 2 only. Right? 2 into 1 will be 2 only. So, x power 0 is equal to 1. Now, so I have 2 x power 0. Now, for x, I am having the power 0. Right? We don't have any other variable. Right? Only one x. That x is also having the power 0. So here 0 will be the degree of the polynomial. Right? See, for x we are having 0. So that 0 will be the degree of the polynomial. Now let us see types of polynomials. The first one will be linear polynomial. Right? Linear polynomial is nothing but a polynomial having degree 1. Right? See, let me take some examples. X plus 2, y minus 5 and some u minus 6. The polynomials of this type. See, here variable is x. The power of variable is only 1. And here variable is y. And for y we have only 1 as power. Here also we have u as variable and it has power only 1, 1, 1. Right? So, these type of polynomials are called linear polynomials. Or it can be any, right? We can use any other variables, but variable having only the power 1 is called linear variable. Let us write polynomials having power of variable as 1. Right? So, polynomials having power of variable as 1. Now, let us see next type, that is quadratic polynomials. Right? Quadratic polynomials. For this, let us take examples. X square plus x minus 2 and y square minus 2y plus 3 and so on. Right? The polynomials of this type, that is the variables having the highest power as 2. In this case, the highest power of variable is only 1. And here, see, here we have the power 1 for x, but the highest power is 2. So, these type of polynomials are called quadratic. Here also 2 and here it will be 1, but the highest power is 2. That is why it is called quadratic polynomial having the power as 2 of the variables. Let us write polynomials having power of variable as 2. Now let us see the next type, that is cubic polynomial. Cubic polynomial. Right? Let us take some examples. X cube plus x square plus x plus 1 and y cube minus 2y square plus y minus 3. Right? See, in this polynomial we have the highest degree as 3. Here also we have variables as x, but for this x we have power 1, for this 2 and for this 3. So, in this polynomial, the highest power is nothing but 3. And here, if you see, for this variable, we have power 1, for this 2 and for this 3. So, in this polynomial also, we have the power 3. That is the highest power 3. So, a polynomial having degree 3. The highest degree as 3. Then it is called cubic polynomial. Let us write polynomial having power of variable as 3. Right? These are different types of polynomials. Right? Linear polynomial means polynomials having power of variable as 1. And quadratic polynomials are nothing but having the highest degree as 2, and cubic polynomials are nothing but having the highest degree as 3. For all these types of polynomials, you need to remember that only the highest power of the variable will be the linear or quadratic or cubic polynomials, right? See, in all the cases, we have considered only the highest power. Here we have only one variable, that is it comes only once, that is the highest power, which is nothing but 1. So, that is linear having the power 1. But in these two cases, we have many variables in the polynomial. But we have considered only the highest degree, right? Remember the point, highest degree. So the highest degree of the polynomial decides you whether it is a linear or quadratic or cubic polynomial, right? Here also we have 1, 2, 3. But this polynomial is called as cubic polynomial because the highest degree is 3. So remember, check the highest degree of the polynomial and decide whether it is a linear polynomial or quadratic polynomial or cubic polynomial. The remaining topics will be covered in the next video. You are welcome to contact us on Telegram to clarify your doubts regarding these topics. Check out the link in the description. Thank you for watching. Please do like, share, comment and subscribe to GeopByte.